All right, so how do I start this warm-up problem? Fred, drop that to value sign. Come on, where's my pen? There we go. Anything else? Christian? Yeah, there's two problems, yeah. Flip the inequality sign, what else? Yeah, make it negative. This is or and. Less than. So it's an and. Okay, remember. All right, it just makes a difference what we look at for our graph then, that's all. Okay? And then this part, once you get your two problems, that's easy to finish it up. You guys are really good at solving equations. And by now we should be, right? Okay? So we're supposed to solve and graph our solutions. So we graph on a number line. And negative 2's down here somewhere, 0's about there, 5's down here. So what do I do with the 5? Keely?
Open circle.
Then what?
Point it to the left.
To the left. Good. Lily? Baker?
Open circle. And then to the right.
Okay. So when it's an and problem, that means the intersection is what we want, where they overlap. So where do those two graphs overlap? In between, right? From the negative 2 to the 5. So any number I pick greater than negative 2 but less than 5 and substitute into the original problem, I'll get a true statement. If I pick negative 2 or less, or a positive 5 or bigger, and plug it in, it won't work in the original problem, okay? So we just drew a picture of all the answers. All right? Questions? Okay? So, answers to the problems real quick. X is less than negative 6 for number 3. X is less than or equal to 5/6 for number 6. Any questions on 3 or 6? So it's okay to get a fraction. If you've got the decimal version of 5/6, that's fine. Number 9, negative 3/4 is less than X, which is less than or equal to 4. And again, I wanted you to solve and graph all of them. I don't know if the directions actually said that, but that's what we're going to do. Some of the directions said use it, express it, like this. These said use set builder notation, and the next group it said use interval notation. But I just wanted you to do the graphing part. Number 12, negative 3 is less than or equal to X, less than or equal to 24. And 15 is when you graph it, it's just the X is less than 1 part that you graph. So it would be a circle at 1 and an arrow going to the left. When you're all done, you put those two together because it was an OR problem. Any of those you'd like me to go over? All right. And then the last few were the absolute value ones. So 18 was 1 is less than X, which is less than 8. So you'd have a circle at 1, a circle at 8, and connect them. For 21, negative 4/3 is less than or equal to X, which is less than or equal to 8. So you have solid dots at negative 4/3 and 8, and connect those. 24, negative 1 is less than or equal to X, less than or equal to 4. Again, solid dots at negative 1 and 4 connect them. And 27 I'd like to go over that one because some of you weren't quite sure at the end what the graph looks like. All right, so there's our inequality. Oh, it's less than or equal, sorry. All right, so my first problem, x minus 4 less than or equal to 0. And since it's less than, x minus 4 is greater than or equal to negative 0, which is still 0, right? So both problems we're going to add 4. So I got x is less than or equal to 4 and x is greater than or equal to 4. All right, so when I do my number line graph, I got my number line. All right, so for this one, we'll do in red. That's like that, right? And this one we'll do in green, and that's like that, right? Since it's an and, I want to see where those two graphs overlap. So where do the two overlap? What do they have in common? Just the 4, right? So the actual graph correct answer would have been just a dot on the 4, no arrows, because that's where the two overlap. Nothing else will work. You know, if I pick 3, 3 minus 4 is a negative 1. Well, the absolute value of negative 1 is positive 1, and that's not less than or equal to 0. You know, if I pick 5, 5 minus 4 is positive 1. Absolute value is also 1, and that's not less than or equal to 0. Okay? If we flip that around and make it greater than or equal to 0, that's when you put the two graphs together. So what's the answer then? You know, if I switch this, and I graph that, all right, I got that one, and it's still the same graph, right, the two? But I'm putting them together now. Not what they have in common, but just putting them together. Yeah, anything works, right? No matter what number I put in there, it's going to work. So that could happen sometimes too, all real numbers. So just want to show you that just for little details. All right, so we good on the basic inequalities, compound inequalities, and absolute value inequalities. You guys did all right on your homework? When I just skimmed them quick, looking at them, seemed to me like you were doing the right thing. All right, today we have two other types, quadratic inequalities, which are quadratics, you know, the x squared, and rational ones, fractions. So those are the two. All right, in the quadratics and these rationals, you want everything on the left and 0 on the right, just like this problem is. Okay? If there's stuff on the right side, bring it to the left. Make the right side 0. Okay? Now, since that part's done, we just factor these quadratics. And if you wanted to use the quadratic form, you can, but most of them factor pretty easy. So there's no GCF. You know, we always look for a GCF when we factor. And then it's got 3 terms. And my A value is 1. So it's one of those, you know, regular, easy trinomials. Only one way to get x squared. You know, x times x. And since it's a negative 15, one of these is addition, one of these is subtraction. So what factors of negative 15 add up to negative 2? Right, 3 and negative 5. Okay? Now, what we're supposed to do, or what we did before when it was equals, we set them equal to 0, right? So if I think about this equals 0, what makes this side 0? What number for x makes that equal to 0? Negative 3, right? What number for x makes this one equal to 0? Positive 5, right? We okay with that? That's what we would have done. We would have been done if we're doing a regular equation, right? Our two answers are negative 3 and 5. When we're doing inequalities, we call those critical values. So when we graph the solution, those critical values break up our number line into 3 sections. All right, we got a left section, a middle section, and a right section. Okay, since it's less than or equal to, I'm going to put a solid dot at both of those because of the equal to part. If the equal to part wasn't there, I'd make them circles. Okay? Now, I got to figure out which direction to draw my arrows from there. All right? And what you do is you pick a number from each area and plug it into the original problem. If that number works, you draw an arrow towards that section. Okay? So that's all we're doing is plugging in 3 numbers. So what number would be easy to use left of negative 3? Negative 4, good. What number would be the easiest to use between negative 3 and 5? 1 would be easy, but there's something even easier. Yeah, 0. You can pick any number you want, but if I can pick 0 as one of mine, I'm going to pick it because it's really easy to add, subtract, multiply by 0. We can't divide by 0. But. All right, what number should we pick to the right of 5? 6. And again, those are the ones I would pick, but you can pick any numbers in those sections. You understand that? Oh, okay, you're not quite finished. I got you. Yes, that's fine. All right, so I just plug into the original problem, not the factored one, but the original one. All right, so negative 4 squared minus 2 times negative 4 minus 15. So negative 4 squared is a positive 16. Negative 2 times negative 4 is a positive 8. And 16 plus 8 is 24, minus 15 is 9. All right, if 9, is that less than or equal to 0? No. So I would not draw an arrow towards that way because that didn't work. All right, in the middle part, I'm going to use 0. So 0 squared minus 2 times 0 minus 15. Well, those are 0. What's 0 minus 15? Negative 15. Is that less than or equal to 0? Yeah. So I'm going to connect those two. Any number in there will work. All right, and then I try the 6 on this end. All right, so I put 6 in for x and see what I get. 36 minus 12 minus 15 is what? 24 minus 9 again, right? And 9 is not less than 0. So that's our graph. So we just pick up a number in each section. Questions? Good? Okay. So, Chris, factor that for me, please. Good. Positive 4, negative 1, another basic trinomial factoring problem. Okay? So what are my critical values, Ryan?
-4 and +1.
Good. So well done?
Yeah.
Thank you. All right, so do I put solid dots or circles at -4 and 1? Circles, thank you. All right, what numbers do we want to pick? -5, 0, and 2. That's what I would pick. Again, you can pick any number you want, though. That's in that section. So, -5 squared plus 3 times -5 minus 4. So 25 minus 15 minus 4. That's 10 minus 4, 6. Is 6 less than 0? No. Put zeros in. 0 squared 0. 3 times 0 is 0. And minus 4. So that's a -4. Is that less than 0? Yeah, so connect them. 2 squared plus 3 times 2 plus 4. That's all positive numbers. Is that going to be less than 0? That's a 14, right? What did I do? Oh, sorry. So that's back to 6, right? It still didn't work, right? Now, my examples both were in the middle, but it won't always be in the middle. Sometimes we'll get on one of the ends, or sometimes both ends. So you still need to check all 3. All right, we good on the quadratics. Make sure what's on the right. 0, everything else on the left. Factor it, and then you can get your critical values. Okay? Sometimes you might factor something that's got 3 factors. Then you got 4 sections that you got to check. Okay? To see where you draw your lines on your graph. So just pay attention to those details. All right, so what do I got to do with that 3? Just like the last ones, the quadratics, I have to have 0 on the right. So how do I move the 3? Anybody? Subtract it, right? Just subtract 3. All right, so I'm going to have 5x minus 9 over x minus 5 minus 3. How do I subtract a number from a fraction? I need a common denominator. What's the common denominator going to be? X minus 5. It's the only denominator, right? Now, what happens to that 3? What do I have to do to it? I got to multiply by that x minus 5, right? Remember that? Because it was 3 over 1, so I multiplied 1 by x minus 5, so I got to multiply the top, the 3 by x minus 5. Okay? So when I distribute, I get 3x minus 15. So my goal is to get it to be a single fraction on the left and 0 on the right. All right? So now I can make it a single fraction because I have a common denominator. So I keep my denominator the same. And then I just do the numerator. What's 5x minus 3x? Thanks, you guys. What's -9 minus a -15? -9 minus -15. That's plus 15, right? So what's -9 plus 15? Positive 6. Okay? Yes, ma'am. Yeah, minus a negative. So that's -9 plus 15, right? Well, I just distributed that, and then I went, negative 9 minus negative 15, this minus and that minus, turn it into plus. All right, we good? So now, you look at the numerator and denominator for the critical values. What makes the numerator 0? Well, if you can't look at it and tell me, just set it equal to 0 and solve that equation. So negative 3 is one of my critical values. What makes the denominator 0? 5, right? So when I go to graph my solution, I've got negative 3 and 5. Now, pay attention. Am I ever allowed to have 0 in the denominator? No. So even though it says less than or equal to at the 5, it's got to be open. Because we're really not allowed to equal 5, right? That gives me 0 in the denominator, which is undefined. Can't be done. Right, Yoder? So at the negative 3, since we got the less than or equal to, we can make it a solid one. Okay, so what numbers are we going to use to check where my lines go, outside or inside? What numbers do you want to pick? Well, do the same as we did last time. What number should we use for to the left of negative 3? Negative 4. What number between those two? That's the easiest, right? What number to the right of 5? Just one to the right, one to the left, and if you can get 0, go ahead and get 0. All right? So we're looking at the original problem. So 5 times negative 4 minus 9 for the numerator over negative 4 minus 5 for the denominator. So that's a negative 20 minus 9 is a negative 29. The negative 4 minus 5 is a negative 9. That's a negative 3, positive, 2 negatives, 3, and I think it's a 0.1 repeating. Is that less than or equal to 3? No. So I would not go towards that direction. Put 0 in for x. I get negative 9 over negative 5, which is 1.8 positive. Is that less than or equal to 3? Yeah. So I connect those. When I put 6 in for x, 30 minus 9 is 21, and 6 minus 5 is 1. Is 21 less than or equal to 3? No. So again, it was the middle two. And again, it does happen a lot, the middle two, but not every time. Questions, first of all. First thing we did was subtract the 3 because we wanted 0 on the right. All right, whatever number we subtract over, we have to multiply by that denominator to make the new numerator so that I can subtract the two fractions and make it a single fraction. Set the numerator equal to 0, the denominator equal to 0. Those are your critical values. And then pick numbers to plug in to figure out where to graph. So, what am I going to do with that 2? Subtract it again, right? So I got 3x plus 4 over x plus 1 minus 2 times what over x plus 1? What do I got to multiply 2 by? X plus 1. Whatever that denominator is, right? So it's not that difficult. Now we got a 0 on the right. Distribute the 2. So I get 2x plus 2 Make your single fraction. Put those two together. What's 3x minus 2x? What's 4 minus 2? Easy to get my critical values. What are they? What are my two values? Thank you. -2 for the top, -1 for the bottom. At -1, it has to be a what? Circle, open, right? We got equal to there, so at the -2, it's solid. What are my critical values? What are my numbers I'm gonna use? To the left, -2. In the middle, -1.5, yeah. To the right, I would use 0. Again, wherever 0 is, I would use it. But it's on the right side now, it's not in the middle, right? Four minus 2 is +2, right? Is that what you're asking me? My critical value is -2, yeah. Right? But that's a +4 minus 2 is just 2, right? +2. So that's where I got the +2 there. The 3x minus the 2x was the 1x. Right? Okay? All right. Any other questions? All right, so we're plugging into the original. 3x plus 4 and x plus 1. So 3 times -3 plus 4 over -3 plus 1. That's -9 plus 4, which is -5, over -2, which is a +2.5. And what's it supposed to be less or equal to 2? Is 2.5 less or equal to 2? No. So this side doesn't work. All right, let's do the 0 since that's quicker. Is 3 times 0 plus 4 is 4, right? Come on. There we go. So I'm doing the right side here. If it doesn't work, then I know the middle should work, right? And 3 times 0 is 0 plus 4 is 4 over 1. Is that less than or equal to 2? No. So it's got to be this one, right? But if you put the -1.5, 3 times -1.5 plus 4 over -1.5 plus 1. All right, that's a -4.5 plus 4 is a -1/2. -1.5 plus 1 is another -1/2. What's a -1/2 divided by a -1/2? What's something divided by itself? 1, right? So is 1 less than or equal to 2? Yeah, it is. So that was the correct graph. Question on the fraction ones. They're pretty similar. You want to, again, have 0 on the right, everything on the left. Once you get it to a single fraction, find your critical values and then plug them into the original problem. So same page, 30 to 45 by 3. Not a whole lot of problems. Probably 2 or 3 of each.